So it looks like we've all made it through the acceleration calculation, and you notice a couple of things about the result. You notice that the magnitude of the acceleration for the smart car is much higher or bigger than it is for the truck. So does that make sense with our intuitive understanding of what's happening here?
Yeah.
Yes.
Yeah.
So if this truck, if our smart car was at rest, and the truck comes sailing along, so smart car's at rest, truck comes sailing along, we notice that there's a big effect on the smart car, right? And is there much of an effect on the truck?
No.
Much less. You're right, it slows down a little bit, but the smart car just goes flying. That's the physics of the smart car, unfortunately. So this corresponds with what we understand, what we expect to happen in a situation like this. Truck comes along, smashes into the smart car, big effect on smart car, smaller effect on truck. Now in terms of physics, the effect is the acceleration. So bigger acceleration for smart car, smaller acceleration for truck. Now our next task is to understand carefully why we have this effect, why we end up with this result. So you're going to have to think very carefully about the role of, let's go back to Newton's second law. Okay. We have the accelerations, but what two factors affect an object's acceleration? And? So we have to figure out the effect of mass and force in this situation to try to explain why we get these different accelerations. This is your next task. Please keep going.